In this problem, we're going to be writing Newton's formula for f of x equals 9x squared minus 2. So Newton's formula means the next term, if you start off with whatever number, like if you start off with 0, and then the next term will be derived from, or maybe you start off with like 0.1, but excuse me, the next term would be the previous term minus f evaluated at the previous term, over the derivative evaluated at the previous term. But we don't have to actually do all that. We're just going to come up with a formula. So we know that our f of x is 9x squared minus 2. And so that means our derivative is going to be 9 times 2 times x, which is 18x. So that means that in our formula, x sub n plus 1 is going to be equal to x sub n minus, so in place of x, I'm going to put x sub n, 9 times x sub n squared minus 2 over 18 times x sub n. And that's the formula you would write. For this next one, this number 5 from Newton's method. It says, suppose you attempt to use Newton's method to approximate a solution of the equation x cubed minus 48x plus 7 equals 0. And let x equal x sub 0 be 4. So your initial thing you're going to start with is a 4. So we want to come up with our x sub 1 and x sub 2. And if it's an undefined value, enter it does not exist. So again, we have our x sub n plus 1 is going to be the x sub n minus f of x sub n divided by f prime of x sub n. So if we're going to say our f of x is this x cubed minus 48x plus 7, our f prime of x is going to be 3x squared minus 48. And just for fun, you could factor out the 3 and you'd have x squared minus 16. And for more fun, that'd be like saying 3 times x minus 4 times x plus 4. Now that's what's going to go in the denominator. So what would you know if you were to put 4 in here and here? What's going to happen? Well, our formula is going to be x sub n minus the x cubed minus 48x plus 7 over that 3x squared minus 48. So if we're starting at x sub 0 being 4, our x1 would be 4 minus, I should have put in here, here, and here. So 4 minus 4 cubed minus 48 times 4 plus 7. Divide that by 3 times 4 squared minus 48. And you can play around with the numerator if you want. I'm going to cut to the chase with the denominator. I'll have a hard time not just doing it, but we get a numerator of negative 121, but our denominator is going to be 3 times 16 minus 48. That is exactly 0, because 3 times 16 is 48. So this is undefined. So this answer should be does not exist. And because this one didn't exist, this one's not going to exist either. So Newton's method fails because our derivative of for the term, or the denominator, evaluated at the x sub 0 is 0. But the numerator was not. So that's how that one works. Okay, for this one, it says use Newton's method to approximate the solution of the equation 3 sine of x minus x equals 0 and we're going to start off with 2 as our initial value. So our f of x is going to be this 3 sine of x minus x. So our derivative f prime of x is going to be 3 cosine of x minus 1. So our formula is going to be the x sub n plus 1 value is our x sub n value minus 3 sine of x sub n minus x sub n, all divided by 3 cosine of x sub n minus 1. So we're going to start off with trying to get x1, and that's going to be 2 minus 3 sine of 2 minus 2 over 3 cosine of 2 minus 1. Now when I do this, I'm going to make sure my calculator is in radian mode because there's no degrees or anything shown, so I mean that's implied to be radian. And so let me get out my handy dandy calculator and we'll do this quick math. Okay, from that I get 2.3237. I'm just going to go to 4 places on that. And actually I'll save that value in my calculator when I do the next iteration, and I just input that value. But that's the idea on this one. Now what I had to do, that I had to be really careful with this, is when I put it in the calculator, I did 2 minus, because it does like a line, parentheses, 3 sine of 2, close those parentheses, minus 2, close that parenthesis, divided by parentheses 3 cosine of 2 minus 1. That's how I put it in to get this value. So to get my next value, x2, that's going to be this 2.3237 minus 3 sine of 2 point, there's my erase button here, 2.3237 minus 2.3237, divide all that by 2 cosine of 2.3237 minus 1. And what do I get for that? And so when I did this, by the way, I'm using a TI-84. I did not actually retype these values in here, 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 or here. When I got to that point, I went up and highlighted and input the output from the previous line so that it had all that stuff, even it has more digits than the display shows. Anyway, with that, I ended up with 2.279595 if I round off to that many places. So that's the other answer. And that's how you get it. And I really encourage people to, instead of trying to write it down and type it back in, to try to use those stored values. And just be really careful with your parentheses. When I was typing this one in here for the second line, for the denominator, before I hit enter, I noticed I forgot a parenthesis, so I went back in and put the parenthesis in. That would have been a frustrating error. It would just said error because it would have had one too many closed parentheses, not enough open. Anyway, I digress. But that's the process for this. I hope that helps. Thanks.